Welcome back to another video on my YouTube channel. Today I will be solving some past paper questions on kinetic energy stores, so let's get started. Today I will be solving question 8 part A from the May-June 2022 session, paper 4 variant 1. Figure 8.1 shows two vertical, cylindrical tubes and a cylindrical magnet all held in a vacuum. One tube is made of plastic and the other tube is made of copper. The two cylindrical tubes have identical dimensions. The magnetic field of the small, cylindrical magnet is extremely strong. Initially, the magnet is at rest at the top of the plastic tube. The magnet is released, and it falls through the plastic tube without experiencing a resistive force. The magnet takes 0.67 seconds to fall to the lower end of the plastic tube. The mass of the magnet is 0.012 kilograms. Calculate the kinetic energy of the magnet when it reaches the lower end of the plastic tube. Alright, so to calculate the kinetic energy, we have to use the formula kinetic energy is equal to 1 by 2 times mass times velocity squared. Next, put in the values which we have. That will be just the mass. So, how do we get the velocity? Now, there are two formulas we could use to get the velocity. Velocity is equal to displacement divided by time, and velocity is equal to acceleration multiplied by time. We can't use the first formula as we don't have the displacement the magnet covered. But in the second one, since the magnet experiences no resistive force, we can use the acceleration of free fall, 10 meters per second squared. So the velocity is equal to 10 meters per second squared multiplied by the time, 0.67 seconds. That would give us 6.7 meters per second for the velocity. So once we input that into our equation, add those values into the calculator to get 0.26934. Lastly, just round it to two significant figures and you're done with this question. Please like and subscribe for more videos just like this.